59% of AP Calculus students can't solve this limit. To start a limit problem like this, the first step is to do a direct substitution, but when we plug 0 in for each x, we end up getting 0 times something that would go towards infinity. This represents an example of an indeterminate form, so we would need to do more work to get our final answer. The appropriate next step for this type of problem is to use the squeeze theorem. The first step is to now understand what is our range as it relates to cosine. We know the function cosine is always bounded by -1 and +1. We will write this. Because we know the range of cosine is always bounded by -1 and 1, we can now start the process of utilizing the squeeze theorem. The goal here is to recreate our problem x times cosine of 1 over x, but now we need to multiply x by each side. Now we have recreated the problem that we started with. Our final step now is to take the limit of -x and of +x. And if it equals the same number, we have our final answer. So in this problem, the limit as x approaches 0 for -x is going to be 0. And then the limit as x approaches 0 of x is also going to be 0. Because both sides equal 0, and we're using the squeeze theorem, so this means the bigger function, which is x, is going to have a limit of 0. And our smaller function, which is -x, is also going to have a limit of 0. Therefore, our final answer is that this limit also equals 0. That is how you use the squeeze theorem. Follow me for more AP Calculus content just like this.